Hi, so the video I tried to make with this at the start got cut off, so I apologize for it partially being filled in, but here we go. So we're just going to go ahead and start getting a review of what it means to graph. So knowing your coordinates, positive coordinate points are here, so that is where we start with quadrant 1. And then we actually go to the left for quadrant 2, down for quadrant 3, over for quadrant 4. So make sure you know where those things are, as well as x and y are positive. But I'm pretty sure you guys have a grasp on that already. So then we are going to put an x in the quadrant where the x coordinate is positive, y is negative. That is quadrant 4. We have to go positive in the x direction, negative in the y direction. That's why the x is there. Then we will graph these points and name the quadrant that they're in. So I'm pretty confident you can graph these, so I will let you do those right along with me. So there are the 4 points. With that, we're just going to go ahead and name the quadrants they're in. So -2, 3, quadrant 2. -4, -1, landing in quadrant 3. 1, 1 lands in quadrant 1. 0, -3, though, is a tricky one here. It is on the axis, so that is a comment we will make about it, is that it is on the axis. However, different mathematicians will say different things. Your book says, though, because it is on the axis, it is shared space. So it is going to be shared between quadrants 3 and 4. So we will put it right there. We will skip this right here. Scatter plots we'll get to in semester 2. Absolute value, something you're familiar with, but something that there's a lot you actually haven't learned about with it. So this is the formal definition of absolute value. This says if you take any number, its absolute value will be the same number if it's positive, but it will actually be the opposite number if it's negative. Another way of interpreting a negative sign is to say that it is the opposite. So if I say the absolute value of 3, well, we know it's the same number 3 because it's positive. But if I say the absolute value of -3, it's got to be the opposite of it because we know the absolute value of -3 is a positive 3. So that's just kind of what this really weird math definition of absolute value is. We will discuss these multi-line equations a little bit later in the semester, actually. So if I'm following then the definition of absolute value, I got to say which one of these things is true. Well, we know the absolute value of -4 is 4. But if I take a careful look here at option B here, it introduces this other part here. And this is what actually follows the definition. Because we see the opposite of the number inside the absolute value bars follows the definition. So here's -4. Here's the opposite of -4, which we know to be +4. Then we know absolute value always turns things positive, and it deals with distance. So we want to figure out, is this actually a true statement? And one thing that helps us when we try to prove general things is to take specific numbers and just try it out. So let's maybe pick 5 and 3. So let's do 5 minus 3. Well, we know 5 minus 3 to be 2. The absolute value of 2 we know to be still 2. But what if I switch those numbers around? What if I do 3 minus 5 instead? Well, 3 minus 5 we know to be -2. And we also know the absolute value of -2 is a +2. So yes, this is true. You could pick anything or any number, any two numbers, and it would work out because it deals with distance. We know 3 and 5 are always going to be the same distance apart. It just matters maybe what direction you're going in, where the positive or the negative come into play. These two, I'm confident you know what's going on with that. Look at this, though. Pi minus 3, 3 minus pi. I think that follows the same thing here. Same numbers, different orders, so we know their answers should be the same. If I think about pi, 3.14 minus 3, I would get about 0.14. Now the absolute value of 0.14 is still 0.14. So how can I express that 0.14 to be exact? Because if we can have an exact answer in math, that's a lot better than an estimated answer. So we're actually going to keep it as pi minus 3 because we didn't change any bit what was happening to the value here. The absolute value did nothing to change that. Let's think about e though. With e, I've got 3 minus pi. 3 minus 3.14. Well, that's about negative 0.14, and its absolute value turns things positive. So positive 0.14. And didn't we just make this positive 0.14's way to be written? So something kind of crazy there. But it could be true that up here we could have said the absolute value of 3 minus 5 is the same thing as 5 minus 3. Take a minute, think about that if you need to, but it works out. Here, this inequality has put a condition on the absolute value here. So with this condition, it says we want to take the absolute value of x. However, the condition is x has to be less than 0. It has to be negative. So what do we know from our definition up above? We know that if I take a number and it happens to be negative, it's the opposite of it. So we want the opposite of x. That's a tricky one to think through, so if you have questions, please come see me. Now we're going to take words and write them into sentences. Distance. Distance between things. You've got to think absolute value. This is an SAT skill, taking some words and building an equation from it. You can bank on having to do that a time or two on the SAT. So if we know we've got some absolute value bars, we got to figure out what are we doing. Well, it says the distance between x and 4. So we've got x and we've got 4. Let me ask you this though. If I pick x to be 6, what's the distance between 6 and 4? 2. I mean, there's 2 spaces between it, 2 tick marks. 6 minus 4 is 2. What if I asked you this? What if I asked you to say the distance between 1 and 4? Well, I bet you do 4 minus 1 to get 3. So there's subtraction going on here when you think about distance. So that's why we're going to say x minus 4. And then we've got is greater than and 12. This also can be tricky to think about how to build this. So if you have more questions about it, please come see me. So in B, I'm going to have you pause the video for a second, try that one on your own, see if you can do that. All right, now that you've tried it on your own, here's what it would be. We've got the distance, so absolute value bars, x, and a negative 5. However, we know subtraction is involved, so when we subtract a negative, turns positive. Then less than or equal to 4. Moving on here, distance formula. Really is just the Pythagorean theorem, but we're going to figure out why. So let's take these 2 dots, put them on our graph. We've got 2, 5, and 4, 0. If I got to think about the distance between them, this is the shortest distance from point A to point B. But Pythagorean theorem makes me think triangles. So where can I get triangles from? If I draw in these 2 sides to a triangle, I could have done it below, I could have done it up above. Either or would have worked. But I make a right triangle, which is what's needed for the Pythagorean theorem. I could count this up. This has a distance of 5, and this has a distance of 2. So the Pythagorean theorem would help us figure out the distance of this hypotenuse, the distance between the 2 points that we're interested in. We're going to come back to that because the Pythagorean theorem says 5 squared plus 2 squared. 5 squared is 25, 2 squared is 4, 25 and 4 make 29. We'll see where 29 comes into play a little bit. The distance formula, though, reads like this. Because I want us to see here how this is going to be the exact same thing as the Pythagorean theorem. So there's your distance formula. It's got x's and y's. You see subscripts, those are those little 1s and little 2s. So that means it's coming from a couple different coordinates. We've got x and y from coordinate 1 and x and y from coordinate 2. So now if I plug this into the distance formula, x1 and x2, subtract those, 2 and 4, and then y1 and y2, I want to subtract those. Now let's think about what those actually equal. So 2 minus 4, negative 2, negative 2 squared, 4. Oh, 2 squared, 4, connections. 5 minus 0 is 5, 5 squared, 25. 4 and 25 make 29. Now I told us to remember 29, because if I do the Pythagorean theorem, 5 squared plus 2 squared equals c squared. In order to find c, I'd take a square root, and I get the square root of 29. That's why these are really the same thing. The distance formula just does the Pythagorean theorem in one step. So with this, we know that this would have a distance of the square root of 29. Now in this class, you'll have calculator, non-calculator sections of the tests and quizzes, because that is what's true on the SAT. So if this were non-calculator, this would be an acceptable answer. I would accept it on the calculator section too, but you could also tell me that it is approximately 5.4, and you would still get credit. Midpoints. We think middle, we think average. When you take the average of something, you add it up and divide it by the number of things you added up. So that means if I have two things, 2 points, the midpoint formula says take your x's and average them. Take your y's and average them. So this is building on concepts you've already talked about. So now if I want to find the midpoint of these, I am going to be taking their points, adding them up, and dividing them by 2. So 2 and 4 are the x values. Add them up, divide by 2. Same thing with the y values. 5 and 0, add them up, divide by 2. Then I will set that equal to what it will be when they get simplified. 2 plus 4 is 6. 6 divided by 2, 3. Maybe you saw 2 and 4 and said, oh, I already know the middle of that. In between that has to be 3. 5 and 0, add them up, divide by 2, we'll get 2.5. Maybe we even thought the middle or the average of 5 and 0 would be halfway at 2.5. If we look at our graph and we go 1, 2, 3, 1, 2.5, boom, there we go. Shows up right there. Our answer makes sense. That's a good skill too to be thinking about in this class is, does your answer make sense? Is it reasonable? Let's go ahead and switch over to the back side now. Another shape that'll come up a little bit in this class will be a circle. So this right here is the equation of a circle in standard form. This is something you're going to want to know. I want you to know too that this comes from the distance formula. It's not a strange formula. It doesn't just magically come out of nowhere. It is from the distance formula because it measures kind of the edge of the circle from the middle. And you could look at the drawing on page 18 to help figure that out from your textbook. Now, you see some H's, some K's, and some R's. Well, R's with a circle would make sense because that stands for radius. So we know that R is going to mean radius. However, the center of a circle is where those h and the k's come from. Because we know that in a perfect circle, all the way around the circle from the middle will be the same distance, that radius. To help that terrible fingered thing make sense, here's the center of a circle, and in a perfect circle we know that this would be the radius, so with this it's all the same distance, hence distance formula. So h and k will represent the center, the radius, from the middle to the edge. But there are three other things that deal with the distance formula called conic sections. One of them you've studied in Algebra 1 and Algebra 2, the parabola. Some of you may have heard of an ellipse before. For example, planets follow elliptical motion. So an ellipse is kind of a perfect oval. And the last one is called a hyperbola. It kind of looks like two flat mirror-imaged parabolas. But the shape of a hyperbola actually is used a lot in communication. So dishes with radios and TV satellites, things like that, have a hyperbolic shape to them. We won't be studying those. They've taken those away from high school math. But I just wanted you to know that those also follow the distance formula. What you're going to be responsible, though, for the next quiz with the circles is that you need to be able to go back and forth between the equation and the center and radius, being able to identify those from the equation or build the equation. So let's start with building the equation. Well, if the radius is 4, we know that r equals 4. In the center, we know to be h comma k. So that means 3 is h and negative 2 is k. So knowing that, we're just going to fill in the template of the equation. So parenthesis x minus, my number for h is 3, squared, plus y minus a negative 2 for k. So minus a negative means plus. So we've got y plus 2 squared then, equals my radius squared. So r squared, or 4 squared, becomes 16. And that would be our equation. Then you would have to go the other way around. So if I look at this and I go, okay, this looks like the opposite, and I would have to subtract a negative 5, that means I could pick out that h is negative 5. Then here I say the y's match up, the minuses match up, so k and 2 must match up, k equals 2. Here though, 10 is equal to r squared, so we got to think, what would that mean the radius would be? Well, I could solve this and take the square root of both sides to get that r is the square root of 10. So that helps us find the radius, but then the center, knowing it's h comma k, means I've got negative 5 comma 2. If you have questions about going either direction, let me know. 10, we're going to skip over it. It says it's covered in P5, but this is also an equation of a circle. This is foreshadowing, and we will need this process of completing the square. But we'll save that for P5 in about a week. The last thing here says on page 20, number 22, go see it, but it says here. Here's 4 points. We've got negative 2, negative 1, negative 2, positive 1, 4, 1, 4, comma 6, and negative 2, 6. We see that this is going to make a rectangle. And then what this problem also says is in the shape that these points make, it wants you to find the area and the perimeter. So area and perimeter, if we think about the formulas, area of a rectangle is length times width. The perimeter is twice the length and twice the width. You might remember perimeter as just adding up all the sides. So we do have to know the side lengths. This has a side length of 5, that has a side length of 6, and we know in rectangles that they'll match up across from each other. So that means that the area, length times width, or 5 times 6, will be 30, and then adding up all the sides, or twice the length and twice the width, twice 5 is 10, twice 6 is 12, 10 and 12 make 22. We will forget labeling these because there is no feet or inches or meters or anything like that to tell us. You could write units or unit squared, but we'll save that. Make sure to let me know if you have any questions, but here is your homework for P2. There you are.